Hi, everybody. Welcome to the December 2023 San Jose Astronomical Association imaging meeting. And tonight we got Alex Ranous, who's going to talk to us all about mosaics. Alex, take it away.
Okay, let's see. Let me share these slides. See if that works. Nothing else has worked so far. It says host disabled participant screen sharing.
Oh, sorry. Go for it.
Okay. Let's see this one. I've two monitors, so it's a little confusing. So, oh, whoa, what just happened? Okay, do you see my slides? Hello?
Yes, sorry, I was muted.
Okay. Are the slides visible?
Looks great.
Okay, let me start. So thanks, hi, for the introduction. Again, my name is Alex Ranous. I'm I'm sure many of you, a software engineer here in the Bay Area. I do all my imaging out of my backyard in Redwood City. I got into amateur astronomy as a youth living in rural Colorado, but when I moved here, I kind of gave it up because of all the light pollution. But I don't know, maybe 15 years ago, I started seeing some of I discovered the APOD site and saw what amateurs were doing. So I kind of jumped back in, kind of dabbled with it on and off, but it wasn't really until I built my own backyard observatory more recently that I've really jumped in with both feet. So for the last 3 years or so, I've been much more active. And one of the things I've been doing a lot lately is mosaics. And the reason I do mosaics is what the reason a lot of people do is that I want to image targets that are significantly larger than the field of view that my equipment has. I image with a 130 millimeter refractor. Its native focal length is about 870-ish millimeters. Focal reducer takes down to 590. I use an APS size camera. So yeah, about 1.5 degrees or whatever of field of view. So clearly there's a lot of targets bigger than that. Another big advantage of mosaics is you can create an image of a target at a very high resolution. I, like a lot of astrophotographers, have this disease called pixel peeping, where we spend far too much time zooming in at 100%, looking at corners and things like that. I really like kind of zooming into some of these giant mosaics because often there's lots of little hidden details in there. The other advantage of a mosaic maybe is if you're making large prints, you get all that extra resolution to really kind of blow it up to big sizes if that's your thing. Now, sometimes you make a mosaic because you just want to expand on an existing image. Maybe you imaged a target and later on you see, well, there's some stuff nearby around there that's kind of interesting. And instead of starting a whole new image, maybe with a lower focal length scope, you just decided I want to reuse the data I have and I just want to tack some panels on this side or that side to incorporate that extra data. And some of us are just gluttons for punishment. So if you want to learn a new challenging technique, mosaics is certainly one of them. Back to what I said about resolution, I took an image recently, I think a 9-panel mosaic of the Heart and Soul Nebula. And when you zoom into this thing, I've pointed out 3 little tiny planetary nebulas that that I kind of discovered accidentally by just kind of zooming around in my data. And had I taken this image with like a red cat or some wide field instrument, I think all these little details would essentially be a couple pixels. So I kind of like these little serendipitous discoveries of some of these objects hidden away in this giant mosaic. So that's kind of a cool advantage of that. Now, clearly, I mean, unless you do a lot of zooming in, it doesn't really benefit you. If you're printing at smaller size, it's probably not necessary, but it's something I like to do. Here's an example of a few more mosaics I did not long ago. These are all 4-panel mosaics. So, this gives you an idea of the kind of my field of view and why I need to go to mosaics. If I want to capture some of these larger targets like the Vale or North American and Pelican, then, at least for me, mosaics are the way to go. Especially since I think my wife, after building the expense of building my observatory, I think my wife would shoot me if I bought a new wide field instrument. So mosaics is the way I go with that. Now, I'm going to show you an example of how a mosaic kind of grew organically over time. A few years ago, when first starting out, I shot this image of the Tulip Nebula. So this is just a single panel. And that was great and all. But then the following year, I saw a really nice image by another imager in Astrobin, and it had a wider field of view. And there was all this cool O3 stuff off to the side. So I decided, oh, I want some of that. So I added 1 panel onto my existing image. So now I have a 2-panel mosaic, and I picked up this little detail. Come to this year, looking for stuff to do, I had recently imaged the Wolf-Rayet at 134, which is kind of in the lower left quadrant of this photo, and I said, oh, that's not far from this mosaic I already have. But in order to get to there, I needed to add a row below and a column to the left. So my 2-panel mosaic became a 6-panel mosaic. Now, later in the summer, looking for some things to do, I kind of couldn't leave it there. Had done a nice shot of the Crescent Nebula, so I said, well, what's going to take to include that? So I added another column to the left of my last mosaic, picked up the Crescent, but it was right up against the edge of that mosaic. So I added yet another column so I could space things out for a better composition. This is a fun mosaic to really zoom in on because there's all kinds of little tiny details hiding around in this thing that aren't going to be visible if you just took a single panel image of this area. So how do if you want to get started in mosaics, your first step is planning it. There's several different software that you can do to use that. Most of the data acquisition software out there has some sort of framing tool and has a mode to let you select to add to create a mosaic. You can say I want this many panels wide, this many panels tall, compose it the way you want. I use Nina as my current imaging software. So I'm going to show some examples with that. In the past, I used Sequence Generator Pro. I think I did 1 mosaic with it, but similar kind of concept. They have a mosaic wizard, or sorry, a framing wizard which you can do mosaics with. My understanding, both Voyager and ASI Air also have mosaic planning modes. So that's my recommendation is to use your image acquisition software, if it supports mosaic planning, to do it in there, because you get the nice advantage that it can generate a set of sequences to acquire that data. You can also use perhaps separate planetarium software. So I know like the SkyX has a nice mosaic planning mode. Stellarium, I guess you can do it with a third-party plugin called EQ Mosaic. Carte Soleil has it. So you can use the separate software to kind of compose your mosaics, but then the trick is to get that information into your acquisition software. I think for some of these things, they got plugins and stuff to enable that. Sometimes you're just going to end up having to copy the coordinates and the orientation into new sequences. So I'm a kind of a lazy guy, so I'd rather just the easier the better. So I do nowadays all my planning using Nina's framing mode. So here is an image of what that looks like in Nina. And actually, I'm just going to jump into, I'm going to do a kind of a demonstration of what that looks like in the software. So give me a second. So assuming I did this correctly, you should be seeing Nina on screen.
Looks good.
Okay, good. So this was, so, you start out, I mean, with Nina, you got like a star atlas where you can find targets. You can, target you're interested. You can set for framing assistant, go over the framing assistants, and boom, there you are. So here's NGC 7822, which I recently did in Mosaic for. And this bounding box is my, my field of view that I have with my camera and with the focal reducer. So that's kind of my maximum size of the image. So clearly this isn't all going to fit in there. Originally, I did like a year or two ago, I did a 2-panel mosaic. So you can go over here and you can pick the number of panels. And I kind of squeezed things in there, but it's still a little tight. I'm leaving some data off to the left. There's some data down to the right. So this year I decided to go all in. So, 4-panel mosaic, you can get it more in there. But one of the cool things about this target is there's this little blob down below, which kind of makes a dot of a question mark. So I went all in on an 8-panel mosaic. So I just add the panels, kind of slide that up. Seems like a reasonable composition. I got the main body here. I got this little thing down there. And, that seems reasonable to me. And then at least within Nina, you can go over here, you can add it to a sequence, or what I like to do is add it to a target list. And so again, if you're not Nina users, I apologize, but this kind of gives you an idea. So here's an example where there's a couple, it's like this target here, SH2, 223, 224. I'm working on a 2-panel mosaic, and they're both separate little sequences. So here's a sequence for one. I could, if I wanted to, I could do both targets in the same evening, maybe spend some time on one, some time on the other. So each individual panel ends up as a separate target, basically, in the sequencer. So that's kind of handy. Going back to the framing assistant, one thing I want to discuss is the alignment of the individual panels. So as you can see here, these panels are a little bit askew from each other. And the reason for that is that each of these panels' rotation is the same, in this case, 0 degrees. But since we're projecting this onto sphere, the closer you get to the poles, the more the panels are askew from each other. So each individual panel is oriented at 0 degrees, but since they're separated from each other, they're askew from each other a little bit. In the further north you go, or south, if you're in the southern hemisphere, the worse it gets. So if I was trying to make a mosaic further up here, as you can see, the further I move, the more askew these individual panels are. And if you are, and this is magnified if you are wider field of view. So let's say you're shooting at, I don't know, 300 millimeters. Let's say you have a wider instrument. So if I had a 300 millimeter scope with this is what it looks like. And so now since the individual panels in each column are further, the centers are physically further apart from each other, they're, the individual panels are all aligned at 0 degrees with, pointing north to the North Star. But since, your lines are converging that way, you end up with something like this. And if you look down at the bottom of some like 1 and 2 here, there's very little overlap. Now you can address that by, you can adjust the amount of overlap as a percentage. I think Nina defaults at 20%, but you can do more if you need it. You can do less if you can get away with it. And clearly the further away from the poles you are, the less of this effect, the smaller the field of view you have. Let me go back to my native, the less pronounced this is. Now, Nina has a nice feature over here called preserve alignment. So if you tick that on, what it does is it squares up all the individual mosaic frames relative to each other. So they're all square with each other. Now, as a consequence of that, if you look over here to the left, there's little mosaic panel area, shows you what the RA and deck and rotation angle of all the individual panels are. And as you can see on the right, each individual panel has their own custom rotational angle. I have a rotator, so this is not an issue for me, as I can just, each panel has its own sequence with its own custom rotation. Nina plate solves and commands my rotator to move to the correct angle. So this is not an issue for me. Now, if you don't have a rotator and you have to use like a manual rotation feature, like my understanding is Nina has a manual mode where it'll plate solve, says, oh, you're this far off, you need to rotate 1.2 degrees clockwise. You make the manual adjustment, do another plate solve, and you kind of iterate until you get the angles correct. And you got like an 8-panel mosaic, and they all have their own custom angles. I could see that would grow old very quickly. So I could see in that situation, unless you have very close to the poles and stuff, you just may leave it in this all with the same angle orientation, so you don't have to deal with that. Just be aware that you may have to adjust the amount of panel overlap to deal with these these converging lines that you get otherwise. The amount of overlap to use, I know Nina defaults at 20%. I've gotten away with 10%. Nowadays, unless I'm really trying to if I just get a little bit more, I can fit this in without another panel, I might go down to 10%, but I typically do 15%. It seems to work pretty reliably with me. So that's kind of how you use Nina specifically to design your mosaic plan. Though I believe most of the other acquisition software is going to have a very similar experience. Though I don't know if this preserve alignment feature is available everywhere. I looked at a couple videos for like ASI Air, which is popular with a lot of people, and it has a mosaic planning tool, but I didn't see any indication that it could do this preserve alignment nonsense. Probably because ZWO doesn't sell it a rotator, so they probably didn't. I don't even think it supports rotators. So that could be a consideration as to which software you use. So let me jump back to my slides. So I already discussed most of this, overlaps. I use 15%. One tip I will recommend for people shooting mosaics is to, when you're starting out, shoot some test images of the entire mosaic. So if you got a 9-panel mosaic, image maybe 15 minutes, a half hour for each of the panels in one filter, let's say hydrogen alpha. And that will let you, like in one evening, get enough data so that you can construct the mosaic, and you can, as a sanity check, to make sure your composition is what you want, all of your panels are lined up correctly, You don't want to be in the situation where you just trust everything worked and spend a huge amount of time on panel one, then move to panel two, then 4 days later, 6 days later, you start assembling the mosaic and realize, oh, damn, this doesn't look great. I wish I would have done it a little bit differently. So I recommend just get the bare minimum of data, at least in one filter for all the panels, construct a preliminary mosaic just as a kind of a sanity check to make sure everything is going the way you want it to. My other recommendation for mosaics is plan for a mosaic much larger than you're prepared to shoot now. I have, with a 2-panel mosaic, 4-panel mosaic, like the example I earlier showed you with the Tulip Nebula, and I added panels onto that after the fact. And at least in Nina, that's somewhat of a pain. You can certainly go in there and create a new mosaic plan, but to get the panels to line up precisely with your existing panels can be a real problem, especially if you don't remember what the offset of the overlap percentages were. It's really tedious. You gotta look at all the individual panels data, compare it with the original ones. It's just a pain in the ass. And the other problem is that maybe with the new panel design, the panels are numbered differently. And maybe your existing data assumes panel 1 and 2. Now panel 1 and 2 are panel 8 and 9 in your new mosaic. Do you rename things? It's just a lot easier up front if, be very optimistic, plan for a giant mosaic if that makes sense for the target, the area. And then, for that season, you may shoot only 2 panels, 4 panels, whatever. Here's an example of the kind of the Virgo galaxy cluster. I had shot Macarian's chain and kind of squeezed it into one panel, but decided to go larger. And so I planned for a 9-panel mosaic, but last year I only shot 4. I only shot panels 2, 3, 5, and 6. So I currently have a 4-panel mosaic of this area, and I'm going to circle back and add the other 5 panels this year is my plan when Galaxy season's in full swing. At least in Nina, you can save your sequences. They're just JSON files somewhere. And what I tend to do is I save the sequence data for all of my images I've ever taken. And you can move them out of the little directory they're in. I have a little archive directory, so I don't have a giant list of targets within Nina. I only have the ones that I'm currently working on, but I can go back into my archive of previous sequence and pull them back. The other tip I recommend is save that mosaic plan, that little image from within the planner with the numbered panels, just so you know what panel is what. So I'll just take a little screen grab of that, and I save it along with all my original subs, so I know what it is I'm doing. So once you've planned for this thing and you've acquired the data, now how do you process it? Several different ways. I use PixInsight. For the rest of the talk, I'll be talking about how I do this within PixInsight. That said, I've seen a lot of praise for AstroPixel processors, mosaic tools that my impression is you just kind of plop all your subs in there, push a button, and magically it processes it all, pre-processes it all, and either creates mosaic or aligns everything. I'm not exactly sure, but apparently it makes life much easier. And I've heard some people purchase AstroPixel processor just for the mosaics. They use PixInsight for everything else, but they used APP just so that they can do the mosaic processing. That said, things have gotten easier in PixInsight over the years. There's some additional tools and things that make life a little easier. So I'm just staying within PI. All my workflows in there. I didn't want to deal with the complication of moving data out of PixInsight into AstroPixel processor and then having to re-import that data back in. I'm just doing it all within PixInsight. So now within Nina, there are several ways of doing mosaics. When it comes to pre-processing data, and the old school way is that you would, for each panel, calibrate your subs, register them, integrate them. I mean, and if you got like 9 panels, that grows old really quick. There's a lot of kind of manual steps to do. With the advent of the weighted batch pre-processing script, it has the ability to process all of your data for all of your all your panels in one go. So you basically load it all into WBatch preprocessor, and you could preprocess and integrate as many panels as you want and as much time you're willing to wait for it to finish.
Hey, Alex.
Yes.
Your title says Nina, but you mean PixInsight, right?
Oh, sorry. Yeah. That's what I meant. Yeah. It's copying slides. But yeah. So in PixInsight, this is what I'm currently using. Now for WBatch preprocessor, they added a feature, I don't know, a year ago, called keywords, which is the key to using WBPP for doing mosaics. And I'm going to jump into PixInsight here and kind of demonstrate a little bit, but I do recommend the set of videos that Alan Block did. Normally he charges for stuff, but he has a number of free videos on YouTube, and he has this 20 video long series on WBatch preprocessor, and there's like 3 of them in the sequence which to specifically talk about the keyword feature and how to use it. So I'm going to do a quick overview of this, but if you want the details, I highly recommend that YouTube videos, and I have a link to the playlist that shows them all, and you want the 16, 17, and 18 are the videos in that playlist that cover the keyword feature. So this is the WBatch preprocessor script. I have a number of slides on this, but I'm just going to jump into PI itself and demonstrate this for you that way so that it's a little easier to see what's going on. So if you bring up the weighted batch preprocessor, which seems to be slower nowadays. I don't know. I think there's a performance regression in recent versions of PixInsight on the Mac, but it's neither here nor there. So anyway, this is the weighted batch preprocessor, and I have all the data that I had used in that Tulip Nebula or Tulip area 10-panel mosaic. And so as you can see, there's a lot of data associated with this monster. One thing you'll notice here is that you see that it is grouping all the data by the panel that they're in. Normally you load a bunch of subs in there, they're all kind of treated as the same object. The key to make this work is this feature off to the right. You'll see something, the configuration called global keywords. You need to activate that, and then you specify, you can add keywords here that is basically specifies metadata that's used to describe your subs for purposes of organizing it for pre-processing or post-processing the data. So as an example here, I defined a keyword called panel, and what WBPP does is it uses that keyword to identify which subs go with each panel so that it can associate them together and organize them such. How it does that is typically this information is included in the name of the files of the subs, or perhaps in the name of the parent directory that contains those subs. So let me give you a quick example. So here is, so for this particular target, I have all my subs in this light directory, and they're each in a separate directory for each panel. And as you see, each directory name has the name panel and then the name of the panel 1, panel 2, panel 3, and so forth. What WBPP does is when you configure the keyword panel over here, is it actually looks at the file names and parent directory names. And so if it finds that string panel in this file name, it then looks at the value separate after that. So either a space or an underscore separate from the keyword in the name of the file or directory contains the value that's associated with that. One little caveat, keywords are not case sensitive. So you see over here, panels all capitalized, whereas in the name of the file or the directories, they're lowercase. That's fine. They're not, it's case insensitive. The values, on the other hand, are case sensitive. So if you're organizing on some other metadata, it's not numeric and the case differs, that can cause it will treat them as two different groups. So you need to make sure that the values are consistently named. Now, if you look at some of these directories, I tend to organize things by the day I imaged it. And the other thing you'll notice here is I have this flats keyword and this temp keyword, which are both defined over here as well. I have a flats and I have a temperature as well. This is handy if your data isn't heterogeneous or homogeneous in terms of the settings. So in this particular example, I had gathered data over several years. Some frames were done at different temperatures. They certainly use different flats. And so if you look over here, the name of my darks, for instance, have the temp in there, and minus 10C, minus 5C. So if you look at the data, you'll see that everything gets organized in terms of temperature, and it uses that keyword so that it matches the subs with the correct dark. So it uses this temp keyword to figure out which dark I need to be using. Similar idea with the flats. I'm not one of these guys who shoots flats with every night that some people do. My rig sits in an observatory, and I pretty much don't touch it unless I'm switching between, let's say, the focal reducer and the field flattener. And when I make a change to the imaging train, I'll shoot new flats, but typically I'll reuse flats for potentially a month or two if I'm not touching the equipment. And what I've taken to doing is I stick all my calibration data again. So here's an example where this for my field flattener, I have different sets of flats that I've taken over different times, and going down here to the individual directories, there's flats 2, flats 4. So that corresponds to the flats in these respective directories. So again, the keyword feature lets you associate your calibration data with different sets of subs, and you can do it all in one shot. So this keyword feature is a very powerful feature, and I encourage you to take a look at that if you're a PI user. The other thing you'll notice here is like panel 10 here, I took more recently, and you'll see that I don't have the temperature there because I've now, with more recent data, I'm incorporating the keyword into the name of the file itself. So I don't need to do it in the parent directory. It's in the name of the file. But since flats tend to change more often, I tend not to embed the flats name into the file name, so I do it in the parent directory. But this lets me, I can go back a year or two later, and I know exactly what calibration data I need to use for that data, and I have it all archived on my NAS, so it's all sitting there. So that's a very, I think if you're doing bigger mosaics, using this keyword feature makes life a whole lot easier. Basically load everything into that. Once it's all set up, push go, and you're done. So the question then is, what do you do next?
Hey, Alex, I have a
So,
quick
yeah,
question. So, when I've done mosaics, I haven't put the panels in the same WBPP run like you are. So, what did you do to tell it not to register them all together?
okay. Good question. Let me go back to that. There is one subtle aspect of this. If you look over here in the configuration, you'll see that there's a pre-column and a post-column. And what this does is it tells where to use this keyword. So for the pre-column, basically, this is telling use these keywords to group subs for pre-processing. So for calibration, registration, that kind of stuff. This basically says, okay, use this keyword to group things. Once everything's been registered and you're integrating things, that's considered post-processing. And this column indicates, so in the case of panel, I'm saying, oh, continue to use the panel keyword for organizing things for integration purposes. And if you go to this little edit thing over here, you can kind of cycle through the different modes. So if I disable post here, you'll see the final thing it wants to integrate all my panels into one one thing. So I got 10 panels here, and if I don't click the post feature over here, it's going to take all 10 panels HA data and integrate it into one messy blob. So you certainly need to go over here and turn on. Now that I turn post back on, you'll see that everything gets put into its own separate panel-based bucket. If you kind of look at the columns over here, you'll see that this is what the keywords it's associated with each grouping of things that it's doing. So over here on the left, so this HA grouping of data is using flats 1, temperature -5C. It's in panel 3. I think I have another panel 3 of HA, which is taken at using a different set of flats. So this organization here is for pre-processing. This is the buckets it's created for all of these panels. So even though I have 10 panels, and since I have multiple different flats and different temperatures, I get a lot of different buckets for all of this stuff. So that's kind of the key to keep everything getting integrated in one messy blob, is you use the post-processing key option in the configuration in WBPP. And again, take a look at Adam Block's videos on this. He goes into extreme detail and explains exactly how all this works. I'm just doing kind of a quick overview because this is about mosaics, not WBPP. But this is a very useful feature for processing your mosaics. So let's say you've done all your pre-processing, and now you have a bunch of masters for all of the different panels. How are you going to actually assemble them into a single mosaic? Well, used to be in PixInsight, you use something called gradient merge mosaic. And when I started to make my initial mosaics, I was using this. Was never that successful with it. I mean, it's fairly a lot of steps. You align a bunch of panels together one by one, and you kind of create a master mosaic panel, at least in one color. And then you register all the other panels to that one for the different filters. And then when you start actually joining panels together, if you got a star sitting right on the edge, you can sometimes get these weird artifacts where the stars look pinched, or there's like little flares off of it. There's a lot of knobs and dials in gradient merge mosaic to try to deal with it. I found that if you're imaging somewhere along the Milky Way, there's a lot of big star field. It's a game of whack-a-mole. You may make adjustments and fix the one problem star just to get another problem star. I think in one mosaic, the only way I can get it to work is I ended up clone stamping a star out of out of the image so that it wouldn't cause problems. So I found gradient merge mosaic to be kind of tedious and prone to these artifacts. Luckily, there's a better way now. So a guy by the name of John Murphy wrote a third-party plugin in PixInsight. It is loaded. I think originally it was supplied with PixInsight, but nowadays they remove the scripts from the default PixInsight, and you need to configure a third-party repository to install them. So I have a link to the repository in PixInsight to get the scripts. And it comes with 3 scripts. There's photometric mosaic, which does the joining of panels, and 2 utility scripts, something called trim mosaic tile and split mosaic tile. Photometric mosaic requires that the edges of your individual panels are very clean. And there's a tool called Mosaic by Coordinates. I'll get into that, but creates the individual panels for merging, and it distorts the panels slightly to get them to all align, and you can end up kind of a ragged edge after the result of that. So what trim does is it basically crops your mosaic so that you get clean edges. So that's what that is. Split mosaic tile is something I haven't used. It is used if you are doing one of these kind of ad hoc mosaic. Maybe, let's say you have a bunch of existing images that kind of overlap, and you kind of want to make a mosaic from it. Maybe they're not a nice grid pattern. What split mosaic tile can do is cut some of these individual images up into pieces, creating smaller panels such that you can end up with a kind of Cartesian grid of panels so that the photometric mosaic can join them together. I don't do that. I create my mosaics from a brand new mosaic plan. They're all lined up in a grid, so I don't have to worry about that, but that's what that is, what's included with this. So how do you use this tool? So this is the basic outline of steps of using photometric mosaic to create a mosaic in PI. Basically, there's 3 or 4 steps. You start with using the script Mosaic by Coordinates, which is a script that ships with PI, so it'll be there. And it is used to analyze all the individual masters of all your panels and figures out how to align them all relative to each other, and produces a new set of panels that are all registered one to the other. So once you have these new panels, you trim the edges off so that they get these clean edges on them. If you have one of these weird ad hoc mosaics, you may need to split them up. Again, I've never done that. And then you finally get to photometric mosaic itself script to actually process the mosaic. So first step of the process is Mosaic by Coordinates. Like I said, you load all of your panels into this script. And I'll do a demonstration of this in a little bit. But basically, what it does is it goes through all the FITS headers of all the files and figures out where each panel is relative to each other. And then it basically creates a new image. It basically figures out what the overall mosaic is. It figures out like the maximum extent of where all the panels go, and it creates this kind of virtual mosaic that covers the entire space, and then puts the data for an individual panel into that space. So on the right, you'll see that this is one panel from a 4-panel mosaic, the upper left panel, and it produces an image with that data pushed into that corner. For this to work, Mosaic by Coordinates requires that all of the individual panels have a astrometric solution. So if you use W batch preprocessor, this comes for free. There's a tick box you can do it on calibration. Say I want a solution, and all the masters it produces have been solved, and all the information that Mosaic by Coordinates needs is in the metadata for that file, so you don't have to do anything. Now, if you are old school and processing things by hand, you'll have to use the image solver script on each of the panel masters to add a photometric solution so that it knows where they all are relative to each other. And then, I have a few slides here, but I'm just going to just jump into PixInsight. I think it's easier to describe it there. So with the first step, Mosaic by Coordinates, this is what it looks like. And you can load your individual panels into here. I've preloaded it with my HA data for a 4-panel mosaic. Now, in real life, you would do this with all of your filters data. You don't want to do HA separate from O3 or whatever, because they may get aligned differently as a result. So you need to load all of your data for all your panels into this tool. Couple ways of doing this. You can either add files, and you can select the individual panels you want to add into this list. Or if you have all of your panels open in PixInsight already, you can just add the windows. So you can go in here and you can select existing open panels, and you can select them and add them this way. I find that especially if you get to larger mosaics, that gets very unwieldy. So you may have dozens of these windows open if you want to use it as windows. So what I tend to do is process files. So I'll add the files to the list. And basically it just, okay, let me explain. So there's a bunch of different parameters that you can use here. I tend to just go with defaults. I go with the default projection. There's different kinds of projections of how it's going to distort the panels relative to each other so that everything registers correctly. I find the default genomic works fine for me, so I really haven't messed with any of these others. But, if you're not getting great results, you may look into that. You can specify the coordinates for all this stuff, but since everything's been plate solved essentially already, it's going to get this from the metadata, so I never have to provide this information. I go with the defaults of everything else. The only thing I do is I configure the directory I want to write out these processed panels into, and click OK, and then it just grinds along. And you end up with a directory full of these little files that look like something like this. So again, here's the 4 panels that have been adjusted by Mosaic by Coordinates, and it's created these 4 new images with each panel shoved into the right place. And if you see, if I blink between a pair, you'll see that, they're perfectly lined up, all the stars lined up. There's no additional alignment needs to be done at this point. Now, so the next step is to trim them. And that's using, again, it's all under the scripts menu in this mosaic sub folder. You want to go to trim mosaic tile. And in here, you can select a window potentially. And here you can tell it how many pixels to trim off of which edge of the image. Now, technically, you only need to trim the sides that are going to be joined with another panel. So for example, in this upper left corner, I wouldn't need to actually trim the top or left because it's not going to get joined with anything else. I only need to do the right-hand side and the bottom side. Now, I found this all very tedious. If you got lots of panels and you got multiple filters, you end up going into each one of these and trimming them, and it grows old really quick. So what I do is, first of all, is I found that 15 pixels always works for me. That's enough. So I just trim all the sides, even the outer edges, because 15 pixels is nothing. If you have like a 6,000 pixel wide image, it's, you know, less than 1% of the total. So I just trim all of them, just make it easy. So I have this pre-configured 15 pixels, all of them. The other trick I'll show you is I do not trim the panels one by one. What I do is I create a icon for this. So I just drag the triangle off here and put this to my desktop. And so this, you know, saves all that state for that process. And I use PixInsight's image container feature. So here you can add, you know, say these are the panels that came out of Mosaic by coordinates. I can add it in here. I can tell it where I want these trimmed panels to go. And then once everything is set up here, you just drag this corner triangle and drop it on top of your previously saved trim process. And then it'll just go through all of these images one by one, trim them, and deposit them in whatever directory you configured for it to output them. So, you know, you got a 10 panel mosaic and you got 3 filters. Well, you know, that's 30 individual panels. It's much easier to do it this way than to try to one by one manually go into trim mosaic and do it by hand. So that's my recommendation is use this image container feature of PixInsight to essentially batch process all of this data. So once your panels are trimmed, you now can start joining them. So I actually say these are all trimmed panels, okay? So I want to start joining these together. The way this works with the photometric mosaic tool is that it operates on one pair of panels at a time. And they have to be windows. It doesn't operate in files. So, you know, once you've trimmed all of your panels, you now have to open them up in PixInsight in order to process them. I typically do it one filter at a time, so I don't open all of my things at one time. I'll operate on what I'm currently working on. But, you know, here's an example where I selected panel 1 and panel 2, and I want to join those together. One is considered the reference view, and the other is considered the target view. And basically what that means is this is kind of the master, and what it does is it's blending the master's data in the area that's overlapped between the two, and kind of merges it in with the target view. I pretty much go with defaults on this. It works for me. About the only thing that I've done is I've selected the combination mode. So basically, when photometric mosaic joins 2 panels together, it can either just basically take the reference view and just overlays it on the target view. Both panels have to be the same signal to noise ratio and gradients for that to really work. So I don't know anyone actually does that. You also have a blend and average mode. The blend mode kind of dissolves from the reference view to the target view as it goes across the join zone. Average basically averages the overlapped from each panel together. I found blend works really well for me, so I use that. But you can play with the other modes to see what works for you. And then there's a million knobs and dials here. And honestly, it just works for me. So I really haven't gone into all of this. If you have more problematic data, or maybe you're, you know, let's say it's much noisier, or there's big differences between panels, you may run into issues, and there's a million knobs and dials here you can do to adjust it. One nice thing about photometric mosaic is it has excellent documentation. Unlike most of PixInsight, which hasn't bothered to document most of the various processes and scripts, this John Murphy here has a very excellent set of documentation with it. and talks about like a lot of these problem areas. And he has a lot of different tools to tune problem areas and so forth. Honestly, I haven't had to delve into any of this, as everything comes out of, at least for me, everything has been coming out of it pretty good. I think that's partially due to the fact I do narrowband imaging primarily, and I don't have any really, terrible light pollution gradients and stuff. But again, if you're having any problems, the documentation here is really good, and he gives lots of examples of how you might address the various things. So let's actually do this. Let's see what that, hold on. So let me join. Oh, let's make panel 1 the reference. Let's make panel 2 the one I want to join. And I'll just grind through this and produce my first joined pair. Let me exit out of this, and this is panel 1 and 2 joined together. You'll see this little highlighted red zone. That's actually a mask of the overlap between the two panels. And so this is the area that photometric mosaic is using to blend one panel to the other. And one of the things it does is it looks at your light pollution gradients, and it makes adjustment to joining panel gradients so that the gradient goes smoothly from one panel into the next panel. And at least to my knowledge, for me, it's worked very well for that, even with the small amount of broadband mosaics that I have done. So, once you finish this, you can close off the little mask here. That cleans up. So this shows the first two panels. Now let's proceed on. Let's go back, pull up photometric mosaic again. Now, since photometric mosaic only works on pair of images at a time, you need to process your images either by rows or by columns. And what I mean by that is, if I used it to say, if I wanted to combine this merged mosaic with the bottom left corner by itself, it would do that, and I would have this kind of L-shaped image. But when it came time to do the next one in the corner, photometric mosaic can only join panels along one edge. And in this case, the corner you would need to join against two edges. So that won't work with it. So you're forced to process these things either by row or by column. So what I'm going to do now is process the bottom row, 3 and 4. And now we have the bottom half of this. And I'm not even quit out. I'm just going to go to the final product. So the first one of this produced an image called Mosaic. The second one is called Mosaic 1. So Mosaic's the top half. Mosaic 1 is the bottom half. I've selected both of those. I hit run. And it's going to then combine my two intermediate results into a single image. And there you go. We close off the mask, and you see that not too bad. I don't see any. I'm going to zoom in here. It's pretty seamless to me. I don't see. I mean, you can see up here, right? They didn't quite line up, so there's this little jagged notch, but for the most part, it does an astonishingly good job of adjusting the relative brightnesses and gradients between panels to create a coherent image. And I've even gotten good results with broadband data where I was fighting light pollution gradients. So at this point, I would crop these black edges off, do the other two filters, and I'm going to have 3 masters, an HA, an O3, and a S2, and then I would process it like I would any other image in PixInsight. presentation, go here. We talked about, oh, so couple things to be aware of when you use Mosaic by coordinates. The order you load the files into the tool matters. So basically, whatever the first file in the list, or window if you're using Windows, is basically the orientation of that panel is the master orientation. Basically, Mosaic by coordinates will make sure that panel is square, so it's not crooked or at an angle. And then all the other panels in your mosaic get rotated to the same orientation when they're joined together. If you have one of these mosaics that, let's say you didn't square out all the individual panels and they're skewed with each other because of that parallax issue, you may end up with, if you choose the wrong panel, let's say one in the corner, it may be a poor choice. So off to the right here, you have an example of poorly chosen first mosaic, and all the other ones are just at this angle, and as you can see on the right, everything's askew. Now, a limitation of photometric mosaic is that the way it computes the mask that it uses to join the two panels together is a rectangle, and it's square, or not a square, but it's oriented, it's level basically. So if your panels are skewed, you can end up with an overlap region that is angled. So if you look here on the right, you'll see that it tapers off to the left, and as a result, the amount of overlap that it's blending goes to almost nothing, and it can lead to poor results. So you want to make sure you pick the first panel in the list such that everything gets kind of squared up as a result. Now, I've had a couple mosaics where I could never seem to pick the right panel. No one panel was the optimum rotation that kind of makes the other panels work the best. I don't know quite how to describe this, but sometimes you end up with these askew panels. So if you go back into PI and go into the mosaic with coordinates script, you'll see one of the options here is rotation. And so for a couple cases, I actually literally have to go in and manually specify the rotation angle of the to use as the basis. So if, let's say your whole thing is composed to be at like a 30-degree angle, more or less, the individual panels may be a little bit off from 30 degrees, but overall, the orientation of the entire mosaic is at 30 degrees. You can then put 30 into here, and it'll make sure all the individual panels are rotated correctly. So this is about the only geometry parameter in this tool that I've ever really messed with, that I've had to use. The rest, the coordinates, the rest of the stuff just seems to work. So, yeah, I already covered most of this, covered that. Oh, again, rows or columns. One thing I tend to do in terms of whether to do rows first and then merge those together, I tend to merge panels along their long edge, I should say. So in my case, what I tend to do is, in this case, I would do panel 1 and 3, and then make a column, and then make a column out of 2 and 4, and then merge those two together. And my thinking of it is, if I were to do it the other way, and let's say I have a large mosaic, let's say 4 panels wide, something like that, and you got this really long edge, you're more susceptible to that position angle being a little bit off, right? So then if you have a very long, let's say you assemble a long row of like 3 or 4 panels, and then try to blend it with the next row, if the angle's a little bit off and it's very wide, you could end up with that narrowing edge on, where the overlap is smaller. So to me, what I want is either rows or columns, depending on the orientation of my mosaic, which leads to the shorter row or shorter column. Whatever's shorter between a row or column is what I tend to make those first. And then that seems to work the best for me. Though honestly, it probably doesn't really make a difference in the end. That's just something that I do. Now, another consideration for doing mosaics is if you have significant quality issues between the different panels. So let's say you shot some interesting target, you shot a ton of data on it. Let's say you want to expand it into a new mosaic and get some of the data around it. Or perhaps you just want to get the region around it so you can recrop it at a different angle. So you have some material to work with. If your additional panels don't have enough data and they're a lot noisier compared to the other panel, then when it gets blended together, you can see the transition from really high quality smooth data to noisier data. So that's something to be aware of. You may find that you have to, sometimes you can fix it with noise correction software, maybe like Noise Exterminator or such. But you may find that even though one of the panels doesn't have a lot of interesting data in it, just to get the background nice and smooth, you may want to acquire more data for that so that when they're joined together, it's not obvious. Another potential issue with these mosaics is if your optical train has some distortions. So let's say your corner stars are pretty ugly. Let's say you have tilt issues maybe, or your sensor size is pushing the limits of what your field flattener or reducer is capable of correcting for. So if your corners end up with these eggy stars, and then you're merging, so that when you merge the panels together in your mosaic, your corners and your edges, where the problem data is, you can see that the merged stars can be some really weird shapes. There is a configuration option when you integrate the subs. Here, let me show you really quick, just so that I recommend you tick. I don't know, PI's gotten really slow for me lately. It seems with each new release with new features, it gets slower. But anyway, when you go to the calibrate, when you configure the calibration here over on image registration, I recommend you click this distortion correction option. So when it registers the stars, it'll actually kind of correct for some of the distortions, barrel distortions or things like that, which makes it easier than to join adjacent panels together. It'll be slower. It takes a lot longer to register panels together using distortion correction, but I find it can be useful to get better quality edges when you join your panels together. So that's one tip I can give you there. Let's see. The other thing you may do if you have really kind of crappy data along the edges, you may want to crop your masters a little bit before you drop it into mosaic by coordinates. So let's say you have really ugly corner stars or something like that, crop 10% off the image beforehand. Now, if you do that, then you're going to have to make sure when you acquire the data, you have more of an overlap. So maybe that's where you use a 20 or maybe even more percentage overlap between the panels, so that because you're going to be hacking off some of those individual edges. One other little tidbit I can give you, if you use Blur Exterminator, I was wondering whether to use it on the individual panels before you join them or after the fact. So I checked with Russ Croman on that, and his suggestion is, especially if you have some issues with your corner stars, is to run Blur Exterminator on the individual panels, but with only the, here, let me just show you, the correction only option selected. So you may go through all of your panels and do this. And so it's not going to do any of the deconvolution or the sharpening. It's only going to correct some of your star shapes, and do that only on the individual panels before combining them. And then once you have a master combined mosaic panel, then you can circle back, turn that off, and do your sharpening and adjustments. So it's kind of a two-phase process. Do a correction only before you join the panels, and once you have a master panel or master mosaic, then you can go through and do the further processing of the data. What else we got? Like I said before, it seems to do a good job with gradients. But in terms of transitioning, so you're not going to have the edge of the panels a big discontinuity between the gradients. It does a good job of adjusting the gradients between panels so that it's smooth, but you still can have an overall gradient over the resulting mosaic panel. So deal with it like you would any other image with, you use dynamic background extraction, or I've actually been using Graspert recently, which is this kind of a separate tool for doing gradients. Using, it's trendy of a lot of software now, uses AI. It's been trained an AI system, machine learning, to how to deal with gradients. And I found I've gotten some really good results with it. I sometimes get as good or better results than dynamic background extraction in a fraction of the time. I mean, sometimes with dynamic background extraction, I have to go through multiple times, tweak where my samples are. It can be a big headache. Whereas Graspert, I don't have to do anything. There's a third-party plugin in PixInsight. This toolbox, I apologize, I don't have the repository in my slides, but this guy has a bunch of these little tools, and one of which is called Graspert, and basically, select which image you want to do, click on this. It takes the data out of PI, runs it through the standalone tool, and then takes the result and re-imports it back in and updates that image. So for all intents and purposes, it looks like a built-in tool. And I found it does a really good job with gradients. So that's something to consider. And let's see, I think I'm running. Okay, one other thing I'll just mention, you may be tempted, I certainly was, to kind of incorporate data from, say, another image of a target into your mosaic. So I'll give you an example. I'm currently doing a 2-panel mosaic of M31. I had shot it before, and I could just squeeze it into a single frame, a nice diagonal, goes right out to the edges, but it was kind of tight. I kind of wanted to revisit it and get a little more room around the galaxy. And so I have a 2-panel mosaic. I was thinking, well, is there a way to take the data from my single panel image and incorporate it into my mosaic? And I figured out a way to do it. So basically, you end up copying all the subs from your single panel into one of your panels directory where it has all the subs there. And you're going to process it and integrate it all together. And the trick is, you have to process that panel separately. You can't just put all the data into WBPP and do it all in one shot. The reason being that the reason is that selection of the master. And I found that when I just loaded a bunch of this extra data that isn't aligned with my panels, is often the automatic registration, so the automatic process for registering images. Oh, sorry, I missed this. I'm sorry, this is incorrect. Before, I should have mentioned that when you register things when you're using these keywords, you have to use what's called auto by that keyword, so it does things appropriately. But the problem with this technology is that there's no way to manually specify a reference frame. So normally with a normal image, if you want to force it to use a specific sub as the master image that all the other subs are registered to when you do star alignment, you can specify it. But when you're doing by panel, you're going to have a separate master per panel, and there's nothing in this user interface that lets you override the registered image on a panel-by-panel basis. Now, you can give it a try, and you may get lucky, and it may choose one of your new data's panels as the master, and it all works out in the end. But I found that more often than not, it picks one of the subs from my non-aligned data, and then none of them line up with my other panel. So I found that you have to go to manual mode, select the panel you want to integrate with, and then remove all the other panel subs. So you're just working on one sub at a time, and then run it through the process for just that one panel. And you can then incorporate this data from your separate image that isn't aligned and incorporate it in there. And I experimented with that. And while it kind of worked, I wasn't particularly happy with the results. I found that if your new panel data, you don't have a lot of it, and you're incorporating all this new data, the single noise ratio of where the old data and the new data overlap is really good. And when you venture out of where the overlap is, you can really see the difference in noise. All of a sudden, you can almost see a line where it goes from very smooth to noisier. So if there's a big difference in single noise ratios when you do that, it may be too obvious. It may be obvious where the overlap is. In my case, I ended up acquiring a bunch of extra data on my new panels to get the single noise ratio up. And once I got to that point, there was really no benefit of adding that extra data. So I've experimented with this, but I don't do it anymore. And final tip, and I've learned this through hard experience, at least on the Mac, on my machine, I find PI has a tendency to lock up and die once you really start pushing the memory. So if you're dealing with like a 10-panel mosaic and you have one of those, 60 megapixel full frame cameras, you may find there's a lot of pressure on the memory, and I've had it lock up. And so I recommend you save your project frequently when processing your mosaics, because you don't want to spend an hour going through processing all these things, merging the panels together, getting it all ready, and then having it blow up in a ball of flame. That's happened to me on more than one occasion. So save frequently, and also helping with memory, kind of do things in batches. Do one filter at a time, for instance, so that you don't have so many windows open at once. And as you merge panels together, you then can go back and remove the source panels with the black space around it. Get those out of, close them off so you're not using up more memory with that. And you'll have a lot smoother time with that. So that's all I have so far. So I can entertain any questions that you might have.
All right. Thank you very much, Alex. Okay. So questions for Alex? Well, I could get started if nobody wants to jump in, but are there any? All right, well, let me ask you. So practically speaking, I've done one mosaic, a 2x2, a few months ago. And, it took 4 times as much data than a normal image. So that's my question. You're shooting in Redwood City from light polluted area,
Yep.
Band. So how much realistically on your images, how much data do you collect for a mosaic, for a 2x2 or a 2x3 mosaic?
Yeah, it kind of depends on the target, how bright it is. But I mean, I tend to, in general, like to get 2 to 4 hours per filter, or maybe more if it's something really dim. Let's say if some real faint O2, or O3, you may want to get a lot more subs for that. So it kind of is dependent on what you're dealing with. One thought I have with, so one of the problems with mosaics is that, if you got a 4-panel mosaic, it takes 4 times as long to acquire all the data. And you gotta kind of dedicate a lot of time to that. One thing you can do, especially if you're not obsessed with pixel peeping and having infinite resolution, is use binning when you acquire the data. So your images are smaller, and you can acquire the data quicker, right? And so they'll all be brighter. So especially if you're doing giant mosaics. I mean, if you got one of these 60 megapixel camera and you're doing a 10-panel mosaic, that the final image, if you don't bin, is going to be colossal. And you really need a gigapixel image. Maybe if you like to zoom in and scroll around, but if that's not your deal, then bin the data. You'll acquire it quicker, and you'll use a lot less memory. You'll process it a lot faster. So now, practice what I preach, not what I do, because I don't bin my data typically, because it's like, if I'm going to the trouble, I want to get as much detail as I can when acquiring it. But that's certainly something you may want to experiment with.
Yeah, I probably picked the wrong target. I picked a pretty dim target, and I had 5 hours of data, saw nothing. Had five more out. Yeah, so I
Yeah,
wound.
I mean, some targets, can take a lot. I mean, I made a 2-panel mosaic of, what's our friend here?
Well, you see the pop balloon there that you have?
Yeah.
That's what I picked, and that was a
Well,
mistake.
so I did the squid as a 2-panel mosaic, and if you've ever tried to shoot that target, basically you can't shoot too much data to pick up the O3. So it's kind of dependent on the target. I did another big mosaic I did is the Spaghetti Nebula. And that thing it's a 6-panel mosaic. It's huge, and it's fairly dim, especially the O3. So that was one of these projects that took a lot of time. And you may end up, if you're going down this mosaic road, you're kind of limiting if you like to process lots of targets, I don't recommend mosaics for you, because you're going to have to devote, a month or more sometimes to some of these big projects. So, this is kind of my 3rd year when I've really gotten into astrophotography again. And so I've shot most of the big popular bright targets. So now I'm either chasing something really dim, or I'm going the mosaic route to get bigger targets I couldn't get the first time around.
All right. Well, I had one more question. At least on the one that I did, I found I really needed to do DBE or ABE
Yeah.
before I joined the mosaic.
Some people do that, and it's I think if you have severe light pollution gradients, the photometric mosaic may have difficulties matching the gradients. So you can certainly go in and kind of gradient correct the individual panel masters before you try to join it. I find with narrowband, my gradients are pretty minimal. So I don't have to do that. My recollection is when I did the Virgo cluster, which is a broadband target, I may have had to do some gradient correction of the individual panels before I joined them. So it kind of depends on how bad your gradients are.
So I have a couple questions, and I went out and took a look at your collection on AstroBin, and it's really impressive. Uh, and also your
Thanks.
presentation was very didactic, and it'll be a nice reference if I ever get crazy enough to try to do another mosaic. I did a couple of them, and I thought I work as a psychiatrist professionally, and we have what we call a sanity check.
Yeah.
After running a couple mosaics, I really seriously needed a sanity check to deal with all the gradients. But
Yeah.
but I just want to ask you a little bit. I'm not familiar with this gradient expert product. I just looked it up while you were talking.
Yeah.
It looks like a standalone Windows program or Mac.
Yes. Well, there's a Mac version as well.
It works pretty well then.
Yeah, I find it's actually pretty impressive what it's managed to do. There's a Ku of the Lazy Geek. I don't know if you're familiar with him. He has a YouTube channel where he reviews a bunch of stuff. This guy in Japan, but he recently did a review of that product and demonstrated what it was capable of doing. And when I saw that, I said, okay, I need to give that a try. And honestly, I haven't played too much with the options. I just kind of feed something in, say, gradient correct that, and the results that came out were like, wow, that's at least as good as what I was doing with dynamic background extraction myself. It is a standalone tool, but there is someone wrote a plugin that basically makes it behave like as if it was an integrated thing in the PI. So you don't even have to.
Because I saw that, I looked in PixInsight and I didn't see it anywhere. And
I need to
see it has to be downloaded separately. So someone has put a plug-in together.
Yeah. So I'm trying to remember. I don't remember the. I'll send it. I'll send an email to the mailing list with the information on that, where to get the repositories.
That would be great.
I don't know. It's one of these, right? I got 50 different repositories in there, and I don't remember which is which.
Okay, well, if you could send it around, that would be great. I'm down the peninsula from you, probably about 5 miles, so I have suffered through gradients just like you have, and so I wind up just doing the narrow band because it just, again, a sanity check is required if I try to do the light, the RGB materials.
Yeah, this is one of the reasons I primarily shoot narrowband, because I'm in light polluted area, and dealing with gradients is a pain in the ass. So I tend to shoot narrowband, which pretty much takes care of most of the gradients. I'll sometimes get gradients in 03, especially if I'm fortunate enough to image when the moon is up at all. So I've sometimes will gradient correct my 03 images, but my HA and S2 I find to be pretty gradient free, or at least not enough for me to worry about.
Yeah, and speaking about narrowband, I mean, I just pretty much do narrowband, but I just wondering if you might say a little bit about how you combine your narrowband channels in PixInsight, because I like your color combination, and it's very similar to one that I like to use also. But it seems as though there's about 5 different ways of getting to that. I used to call it the Cal colors. Being at Stanford, we call it, the blue and gold colors.
Yep.
And so I just wonder what process or what workflow do you have for putting that nice color together? Because the one I have works, but it drives me crazy also.
Yeah, I know there's a number of tools and scripts to do combining your narrowband data together. I've played with the various ones. I've not really been happy with, maybe because I didn't spend enough time. My process is rather manual and kind of seat of the pants. So I'll stretch my individual narrowband channels independent of each other. And I do my combination once they're no longer linear. And what I tend to do is I'll work on my dimmer, HA tends to dominate if you just slap them together. So I tend to do extra stretching and manipulation of my O3 and S2 data. And over the years, I've become very adept at curves. So
Yeah.
I know there's a lot of people use all these fancy pixel math expressions or use these special tools where they can, do various percentages for the different channels when they're combining it. But honestly, I'll stretch each individual channel independently of each other so that they have kind of a similar brightness levels at that point. So I may do minimal stretching of the HA and get kind of aggressive with like the O3 if I want to bring that out before I do the combination. So that's kind of how I get it. And then sometimes I'll use this 4X palette. You may have run across one at a time.
Yeah.
That tends to be, I kind of like some of the golds. That tends to be a little too red for me. It looks more like an HOO image to a certain extent. So what I may end up doing is doing it both ways and then blending the two together in pixel math. Maybe 70% of the one way with the pure SHO and maybe, take 30% of the 4X palette. So someone else asked me about my process. And it's, years of using Photoshop. I mean, it's like, I'm really handy with curves and using these tools. So I get acceptable results. And so to a certain extent, I really haven't learned some of these. I know there's a whole new suite of scripts and utilities out there for doing narrowband combinations and color things. And, I've played with a few of them, but I'm not getting any better results of my old way. So, old dogs, new tricks. I just kind of do it the way I've been doing it. But it's not a really easily repeatable pattern that I can describe to someone.
Yeah, no, well, it looks very good, and I didn't think there was a simple recipe to it. Because I've been using this GHS general hyperbolic stretching
Yeah.
routine that's been around, and we've had lectures here about that. And at the end of the day, it's more of an art than a science.
Well, that's for sure.
Because of that stretching, because you just hit it with a grasshopper's eyelash on some of those sliders, and you get dramatically different changes.
Yeah, I've used I've used that tool as well. I don't use it typically. I guess I haven't spent enough time mastering it, but I find that I get the same level of control with curves. I mean, I can set my points very specifically along the curve and lock things down. And, I can take samples of my image and say, how dark is this? How bright is that? Okay, this is my background. Let me lock it in so I'm not boosting that. So I can do some really subtle stretching in very narrow areas just using curves.
Sure.
So I'm a curves guy. I
Yeah.
learned curves in Photoshop, and that's just what I'm used to. So that's so I'll do the initial stretch. Actually, what I've been using is there's this what's this toolkit called? The Easy Processing Suite. And they have something they call the soft stretch. And it's just using normal histogram stretching, but it uses this kind of iterative algorithm or something to I find it gets pretty good initial results. So I'll do initial stretch with that. And then I go to town with, kind of get it out of the linear zone. And then from there, I tend to I use curves. I'll use, I don't know, local histogram equalization, those kind of the tools I use to manipulate the brightnesses of things so that they blend together once I do the combination to get a color image.
Yeah. Well, you've kind of gotten the guy here to give you the interrogation, but I just had one more question. You always say just one more question, but
Sure.
the other thing that drives me crazy, there's lots of things that drive me crazy in astrophotography, but I assume that you're probably de-starring your images.
Yeah.
And then putting the stars back in.
So yeah, what I didn't mention is I'll use Star Exterminator to remove my stars while linear. And then because I don't, especially since I'm a curves that job and I'm really doing some manipulation with ones that can really throw your colors off. So I like to get the stars out of the picture, so to speak. get my starless images the way I want combined, and I'll separately stretch my extracted stars. And then I'll just stretch them to the size and that I want. So I know a lot of people do all these tricks to do star reduction. I don't do star reduction. I just only stretch it to the point where they look good to me, and I stop there. So I don't have to do any of these star reduction techniques because I never make them big enough to begin with. Sometimes the star shape isn't great, especially if the scene was kind of poor. Like if I just recently did an image where I shot some RGB just to do stars on my narrowband image. And it turns out the night I chose to do it, the scene was rather soft. And blowing the stars up to where I wanted them, they're still kind of soft and have a kind of a poor Gaussian shape. So what I'll do sometimes is I'll stretch my color stars, and then I'll extract stars from, like, say, my HA, stretch those and use that as a luminance mask. So I'll do an LRGB combine where I'll take my my HA stars, which may have a better shape, and use that as luminance on top of the color data from my RGB stars. And I find that can fix up some problematic RGB data.
Well, look, I really appreciate your comments.
Sure.
Those are the things that drive me crazy. And
yeah.
never any solution, but I think you get a couple more tools in the box there to help you out with each one of those.
Right. And when I do my stars, like if I don't shoot RGB, before I do any stretching, I will make a HOO combination, because I find HAO stars colors to be a lot more closer to the RGB values than if you do I find SHO stars tend to be yellow and kind of ugly, and you don't get any, So I tend to make, especially with mosaics, I don't shoot RGB with big mosaics because it's already taking bloody forever to get all the narrowband data. I don't want to spend any more time shooting RGB. So I'll use HOO stars. I'll combine them while linear. I'll use I'll use SPCC, the spectrophotometric color calibration, and it has a mode where you can tell it's a narrowband filter, and for each of them you say what's your bandwidth of the individual filters, and I find it makes some pretty good stars. I mean, the colors are pleasing. They tend to lose blue stars and stuff like that, so sometimes I'll shoot RGB, but for the most part I find that the stars I get out of HOO combined works pretty well. So I'll do it while linear, do the spectrographic spectrophotometric color calibration, then extract it from that HOO image, and then I'll stretch that into nonlinear land and combine it later.
Well, thank you. That trick right there, I was not aware of that tick box. So I appreciate it. It goes to show, you just keep asking questions and eventually you'll learn something. So
yeah,
thanks very much. I really appreciate the comments.
Sure. Any other questions? Or
I wanted to thank Alex. This was a great presentation on mosaics.
Thanks.
I tried to do some mosaics myself, limiting myself to 2x2 so far, but you really gave me some motivation that I probably was lacking to go beyond the classic 4 panels. So thank you.
Right. I found that I tell you what really helped my mosaic journey in terms of data acquisition is build an observatory. If you're doing this night after night and you have to manually set things up, or drive down to Pinnacles or something like that, and you need to acquire 50 hours worth of data, that grows old pretty quick. So the fact I have an observatory is really handy, and the rotator, let me tell you, man, that's been a game changer for me in terms of convenience of not having to have to manually orient things, or at least give you the flexibility. I mean, before I had the rotator, I tend to, everything's oriented at 0 and 90 degrees, basically. And, especially with mosaic, if you're growing really big, you may want to orient it, right? If you're trying to get targets that are spread diagonally from each other, you may need to orient the whole thing. And trying to get all of those individual panels lined up is just Get a rotator. I bought one of these Pegasus Falcon rotators. It works pretty well. I just noticed they discontinued it and they have a new model.
Yep.
So maybe it's better. I think my rotator introduces a small amount of tilt, but again, I don't have a full frame camera, so it's barely, I mean, it's only detectable in analysis tools. By the eye, the stars look pretty good. So I have some dilt in there, but you know, honestly, unless you're blowing up to 400%, you'll never know.
That's good to know. And on this, I have a second question, if I may. So when you do rotations and you have to change the rotation from one panel to the next, so do you take, I assume that you take specific flats per the rotation, per rotation angle?
I don't. I'm a lazy guy. So I know some people do, and there seems to be a lot of, some people are very obsessive about their flats, and if they change anything, they'll shoot new flats. I did some comparisons with my rotator. I'll take a set of flats, rotate it 90 degrees, take another set of flats, subtract one for the other. And there are some minor differences between the two, but honestly, after they're applied and I compare the results, it's so minor that I find that it's not necessary to do it between rotation. Now, I invested in a very expensive astrophysics refractor and all their stuff, and everything is orthogonal and precisely aligned. And I think that makes it easier. If your image train's a little more fluid, so to speak, you may have some more difficulties there. But you know, I personally, so I literally have a library of flats like I would darks. And I'll use a set of flats for potentially a month or two. And it's only when I take apart the imaging train, mainly to swap between a field flattener and a focal reducer, that, you know, I'm opening it up, some dust may get in there, may get some new dust motes. So I'll a matter of course, if I make any physical change to the imaging train, I'll shoot new flats, but otherwise I don't bother. Especially with narrowband. I have one of those flip flats panels, which makes shooting new flats easy for RGB. But I found that the red response of this panel is so poor that it may take multiple minutes to get enough data like an S2 to get a reasonable flat out of it. And if I'm shooting a dozen of those, oh God, that grows old really quick. So I found make a library and you're good to go. At least works for me.
Thank you very much. I did not know that. It's good, very good to know.
Yeah, a lot of people say, oh, if you do anything, make any change, you need to shoot new flats. But I mean, you're dividing your flat into your data. I think if you have a lot of vignetting, maybe if your optical system isn't really flat, let's say you have a lot of vignetting in the corners, it's more, your flats are more extreme. They may be more sensitive to the things. If I had a full frame camera instead of an APS size camera, I might be more susceptible, and I may, with rotation, I may want to shoot new flats, but so far, not a problem. One advantage of having a smaller sensor.
And even in that case, not only you need to have a lot of vignetting, but also needs to be asymmetric. So
yeah, my system's pretty, I mean, when I rotate, basically, the vignetting really barely changes. So mechanically, one thing you're getting with an astrophysics telescope is that mechanically, those things are cut above almost anything else, just how well they machine things and everything. So I find that your optical train stays really well aligned, even when you move things around. So kind of depends on your equipment. I think if you have nothing quite as solid, you may have more issues with your flats. I don't know.
Thank you.
Again, you spend enough money, a lot of these problems.
Yeah, right. Thank you very much. And public service announcement for Jerry. I posted on the chat the link to the repository for the PixInsight toolbox. And
oh yeah, that's good.
And some good tutorials on the classic Hubble palette, which is the one I think you call the Cull palette.
Oh, well,
yeah, that's actually one of the scripts I played with. They have, that's one of the many third-party scripts that you know, they have like he has a script to combine HA with RGB. which I haven't played with. It's on my to-do list. The next time I get to that Galaxy season, that's the next thing I'm going to play with, is incorporating HA into my RGB galaxies.
Well, I appreciate the reference, but I just hit that first URL and it came up not found. So maybe
Yeah.
it's
Because it's not supposed to be visited by you with a browser. You have to put the URL inside PixInsight.
oh, that's a
And then-
repository.
Yeah, yeah.
Oh, okay. Thank you. I'm sorry. I'm you know.
And I think that's the model PI is going towards. I know they used to bundle a lot of scripts with PixInsight, third-party scripts, but I know in the case of photometric mosaic, it used to be bundled with PI, but the author asked to remove it from PI because he wanted to move to using repositories. And it gives the third-party guys a lot more flexibility. They can update it whenever they want. They're not beholding to PixInsight's release schedule for getting changes in there. So I think going forward, you're going to see more and more of these scripts disappear out of the base distribution and require these additional repositories. I would love it if they produced kind of a third-party script app store or kind of a central repository to navigate all these third-party scripts where people could register and you could see what they all are. But right now it's just like, okay, oh, I heard about this on some YouTube channel. So, I mean, that's kind of how you discover a lot of these.
Yep. So basically, it would be nice if there were a central repository like Nina has for plugins.
Right. I love Nina's little plugin directory. Like, you register, you supply your thing to Nina, they put it somewhere. It's available in the little drop-down list, little descriptions, and you can kind of easily discover all, oh, wow, that's cool. I could use that. Whereas with the PI third-party things, it's like, how do you discover these things? You got to spend a lot of time on the forums or watching the latest YouTube influencers channel to see where to find these things.
Yep.
All right, do we have any more questions for Alex? Well then, thank you, Alex. That was an excellent.
Thank you. That was fun.
Everybody, please unmute and give Alex a hand. We'll end the
Thank you all.
All right, bye everyone, and see everyone next month.
Thanks a lot for everything.
Thank you.